May the 3rd, 2016. Guys, you're looking at Earth-facing images from the Solar Dynamics Observatory, a satellite that gives us this Earth-facing view of the sun. Top left corner, that sunspot you see just on the edge that's very active is the one that we saw go around the right edge of the sun a few weeks ago. It was the largest sunspot of the year, and it caused us a very strong flare, several coronal mass ejections, and it was running at peak while CERN was running at peak. Remember that? Now, in the last video I did, CERN had said they would be up Friday or Saturday because of the what I call a bionic weasel that dug down 400 feet and ate through a high voltage cable, 66,000 volts. It's very hard to even cut through one, but it did, according to CERN. Now, as they see this sunspot emerging, in my opinion, they're rushing to have it up in 2 more days. In the very last frame right there, you can see it start to emerge. It's trouble because it is connected magnetically over a very large area of the sun. It has been since it went around. Again, you can just see it start to edge up. Now, let's switch to the backside of the sun and go to stereo A. Again, I'm very happy that this year it emerged from behind the sun. It's in Earth's orbit, 1 AU on the other side. This is what it looks like. This is the large sunspot that gave us all the trouble. And we'll look at the alignment that's going to be facing this edge of the sun as it comes around. Now, you've got about a 27-day or 27.5-day rotation on these sunspots. Now, we're going to watch 2 comets coming in the last few days. There's a small one that has followed the larger one that you saw. Now, it doesn't look that large from this side of the sun. Remember, the sun is the white circle behind that disk. There's your first comet. It gets brighter as it comes in. These are called sun divers. It kind of came out of nowhere. No one was expecting it. You'll have to look very close at the same exact area, and there's a trailing object right there. Probably same of the parts of the same original comet. As these things break apart, especially after they made a orbit that brought them close to the sun. That perihelion slingshot effect will break them apart. There's your first one. Again, very impressive because it was a backside comet. And I'll tell you why I know that, and I'll show you why I know it in just a minute. But there goes the secondary piece right there, guys. Now, same satellite, different camera. Let's go to LASCO C2, much closer. Now, remember, the sun is the size of the white circle behind this disk. This disk is put there to block the glare so we can see what's going on around the edges. If you notice the satellites that show the sun, you don't get very much from past that point because it's filtered so far down to get those images, nothing else appears. Again, same time stamp, but this LASCO C2 camera gives us a much closer look. There comes your first comet. We'll play this thing through. Now, that coronal mass ejection that you saw as the comet was approaching on the 1st, we're going to get a side glancing blow of that in the next couple of days. Not a direct hit. Let's go back to stereo A on the back side of the sun. You can tell the comet was much larger. Remember, the sun is the size of the white circle. That's telling us it was back on this side closer to the camera, but it was large even as it dove into the sun. But it came in from the back side. This is also a stereo ahead, different COR2 image of the size of that comet. Impressive. For a sun diver, you don't see them that large. Now, we got 3 planets that are lining up now. Earth is the one in the center. The reason it doesn't appear to be moving is because this camera on the other side of the sun on stereo A is focused on it, and it's in the same orbit. The reason I'm showing it to you is right there. That was a miss on the 26th, the one we were watching for. We got a glancing blow. Remember that? It was very impressive as far as a coronal mass ejection. You're looking at a cloud of density larger than all 3 of these planets combined. But it went below us and to the right. Check that out. Tremendous amount of energy. We'll look at it, same satellite, different camera. I'll show you, it's a little clearer picture. You got Mars, Earth, and Mercury. You see that? Mars is further away. It's the 4th planet Earth's the third, Mercury's inside that. Again, Earth appears stationary, but it's moving faster than Mars, but slower than Mercury. You do not see the coronal mass ejection as intense in this camera, but it gives you very good optics. That's 2 million miles away from our planet as far as the camera. Very impressive indeed. Now, one thing we got to watch for, that sunspot's coming around on this side. Stereo A is reaching out from behind the sun, but look at what we're dealing with. This was from 2 days ago, but stereo A is to the left finally, and we can get the signal. Mercury, Earth, Venus, Mars are all going to be in play, but Mars is behind Earth as we're starting to go through this period. So we're going to see it somewhat of an alignment. We'll look at it on the couple of other models too, but that's what we're seeing. Notice it's in the same orbit as Earth. Earth is in the green dot, stereo A top left. The reason I say that, Earth is 1 AU away from the sun, 99 million miles. So is the stereo A, but on the other side. So we've got about 198 million miles of signal traveling to give us those images. Now, CERN is rushing to get back up. Today, they even cranked up their beam in energy without having collisions in their beam 1 and beam 2 intensity. Notice they're running at 0 tera electron volts. Last video, they said they were going to try to have the 66,000 volt transformer back up by Friday or Saturday. Notice it dumped on April the 29th. They haven't had it back up since that point. That's when we got this 4 pattern configuration, both beam 1 and beam 2. Never seen that before, and you guys, we saw this in the last video. A lot of interesting comments about what that was. But again, it was at the time it was dumped when the large transformer went down. Now they've changed the information. They are starting to ramp back up. Wednesday, Thursday morning recovery from faulty transformer. Thursday onwards, they will resume the beam operation and feel for physics. Daily meeting at 8:30. Ascension weekend meeting at 9 o'clock. They're going to be running 25 nanosecond trains of 288 bunches. That's a lot of bunches, guys, and they back up now to 50 bunches in those trains at 6.5 tera electron volts per beam. As they collide, you get the 13 TeV. But remember this, when we see the peak on the different CERN monitors, it's always a flatline clip. That means it's not going to go, that meter is not allowed to go beyond that point. It's clipping out. They can set that level. So we don't really see the true peaks in them, but we've seen them go beyond that a few times. So now we've got the big sunspot that became active when CERN became active last month. What will we see now? Will we see an intensity in flares? An intensity of coronal mass ejections as this thing cranks back up? Remember, as it achieved luminosity, that was when we were having the most powerful quakes. Did tremendous damage. Guys, they're sending ultrasonic waves when they're dealing with, you're dealing with a magnetism and the force of the magnetism that's 100,000 times more powerful than our planet. This resonates through our planet like a bell, and it causes these quakes. It causes a collapse in our shields. We're starting to see the UV index across the nation and across the planet shoot up into 11, which is extreme. You only have minutes before you can burn your retinas. Check it, the UV out in Miami today and down in that area, other places in the United States. Guys, that type of UV occurs when our shields are down. Remember the video a week or so ago when we saw the total collapse of the shields for 2 hours and all of that energy was trapped within our satellite bands? That lets a tremendous amount of radiation in. And you see these high UV days start to build up. It's not good, but just go to and type in UV indexes, put in your address or put in your zip code, and there's a rating. When you start getting to 8, you're in the high level on that UV index. 9 is higher, 10 is high, 11 is extreme, and there's several places, maybe 4 or 5 cities in the U.S. today that will achieve that 11 rating. But guys, we're watching this as a heads up. Be safe.